Welcome, Professor Meyl, to White TV. We are very proud that you give time to us, because for me you are the greatest scientist in the world just now, because you detected very, very important things in physics, basic things, which other physicists have searched for since a long time and not found or not solved the problem. And you're a fan of Nikola Tesla, I am. A lot of your research is based on it, so we are very curious to listen what you have found.
Yes, let's begin with the beginning. My education was about eddy currents. I calculated eddy currents, and so field physics was my special field in this part of electrical engineering at the Technical University of Munich, and later on in Stuttgart, where I made my PhD in calculating eddy currents. But at that time I found out that these opposite or these contrary vortex is missed, because we know from mechanical vortex systems that we always have two. One is expanding and one is contracting. And the contracting vortex is forming a structure. And in electrical engineering we have only the expanding vortex, which is the eddy current vortex. And so this missing link I tried to fulfill. Well, when I had been professor, not before, when I have reached what I wanted to reach in my jobs and so on, then I started with this scientific work. That was in 1990, when I first wrote a book about potential vortex. Well, the hydrodynamic vortex is called as well potential vortex, but potential in this meaning is the electrical potential. That means the voltage, and this is a bit different. And I found out that in the Maxwell theory, this vortex,
James Clerk Maxwell,
yes, of
Great Britain in the 19th century.
Yes, this potential vortex has been put to zero. And I first tried to find an answer to the question, what will happen if this vortex would exist? So I tried to find out what the results, and in this book I have found out that the human being is using these vortices, especially in the brain, for storing as a storage device, in the vacuum perhaps.
Memory.
Yes, a memory. And well, and then and in the nerves, the control systems, and nowadays as well that the DNA, the reading and writing of the information is using scalar waves. That means using this potential vortex, because we need this forming system, which is
cells are using it.
The cells are using it. So we have a lot of examples, and that was when I started only with a question, and the book was named Potential Vortex Part 1. So this is the new book, because I renewed it this year. It's
not translated to English yet. Yeah.
Not yet, but we are working on it. And the original 20 years ago has been not translated as well, so it was only in German. And that's how I started. But the problem in physics is if you have a new idea, that means if you have a new effect or phenomenon, that you are using in field equations in addition. Then you have the problem that these closed system could be unclosed at the end. So there you have effects which are in contradict to other effects. And this is why I had to change this field theory. I had to replace one effect by another. So the potential vortex is replacing the vector potential. And this is a problem in electrodynamics. And another problem is that my derivation, especially my starting point, my Ansatz.
Yeah, the starting point in thinking.
Approach. Yeah, now I have it. My approach was involving magnetic monopoles. And these magnetic monopoles at that time did not exist. That was the opinion.
Not known or recognized.
Were not recognized. Famous scientists like the Nobel Prize winner Paul Dirac said that they have to exist. We have to look. We have to search for these magnetic monopoles because this is a missing link, and we need it. And this was his opinion, and nobody was able to find it. So this was only at 2009 when they have found these Helmholtz Society, the biggest German society, research society. They have found it in Berlin and in Dresden, and they have opened the way for me, for my approach, for my calculation. So
but you were first predicting it.
Yes.
And attacked by that.
20 years before, nearly 19 years before. So I still have published all the consequences. And the Helmholtz Society have not seen the consequences. They only have seen that they are able to watch that magnetic monopoles in spin eyes in a very special situation are observable, so and detectable. But this is, my problem that I had to wait for 20 years till the way was free, not before.
Like Tesla, you were ahead of time.
Yeah, or Tesla was an experimental physicist. I would compare it more with Maxwell, because Maxwell had to wait 25 years, 24 years about that between his development, his description of a wave, electromagnetic wave, and the proof by Heinrich Hertz in Karlsruhe, 1888. So this is a long time. He had to wait, and in that time you have all these problems that first nobody is accepting it, they are ignoring it, and then they laugh about it, and then they fight against it, and at the end maybe they buy it or whatever. Maxwell was dying very early, so he couldn't feel his success at the end. And Okay. So this is typical in science. If you have a new idea, you have a lot of scientists who don't like it because, they have so many papers published, so many books, so many scientists in their institutes working on it and writing PhDs and so on. And if they have to accept that everything is nonsense, that they start from the beginning again, they don't like it. This is typical.
How is this new vortex, this potential vortex you gave the name to it, connected with this magnetic monopole?
Only by the equations. It's a bit difficult to explain. I need the equations to show that from the law of induction, if I expand this by these potential density vectors, then these potential density vector, which at the end are the cause for the potential vortices, then I'm able to build the divergence on this equation. That means the equation of continuity, it's called. Then I find out that this new vector, as a consequence, has magnetic monopoles. We know this in a dual situation from the currents, whereas the current density, which is as a consequence has these eddy currents, is described by electric monopoles, which are the electrons which move. If they're negative charge, if they move, they are carrying the current. They are the cause for the current density. So here we have magnetic monopoles as a cause for the potential vortex. But at the end, this is not important for me. Only because I don't need these magnetic monopoles as monopoles. I need that the third Maxwell equation is not zero. This is a bit different, you see. The fourth Maxwell equation, divergence D, is describing the electric monopoles. This is accepted. And the third Maxwell equation is describing the magnetic monopoles. And this has not to be zero. This is the problem, because Maxwell had put it to zero. That means exactly the later on the Heaviside has done it. Yes, they have said we only accept what we have proved, and only the Hertzian wave, electromagnetic wave, is proved. So all the rest we put to zero. This was the thinking. It's okay, but you always have to prove this situation. At that time, 100 years ago, it was correct. It was okay. But nowadays, nobody is proving it, you see. If you put in a field equation, in such a system, if you put something to zero, you have to prove whether what you put to zero is really negligible, is very small compared with the other. But if
they couldn't prove it.
They don't prove it. They say the equations say it is zero, and then we don't have to look at it. So this is the problem if you look at the maybe mobile phones, which are sending this part as well, but nobody is accepting. They are not measuring. They are not realizing, because they say it's up to the equations. It's zero. And that was really laughable and when these gardeners in Berlin, they were illuminating their gardens with lights, with these lamps. Remember? Because when Berlin was an island, there was no place, so they had the gardens under these antennas of Rias Berlin, and then they could use these scalar wave part, this part,
not electromagnetic parts.
Yes, not electromagnetic parts, and these parts are able to, are carrying energy and are able to illuminate these fluorescent lamps. And and then there was a fight, because they said, well, the electromagnetic wave we are not using. So what is your problem? And the providers of RIAS Berlin.
It's a broadcasting station.
Yes, yes. At that time, it was. They said, "We are able to prove it. If you switch on your lamp, I see it. My ampere meter is showing that you have switched it on." And that was a problem because the theory of Maxwell have put just this part to zero. You see, it's not
because in the usual radio wave, electromagnetic wave, there is not the reaction or the interference in between. They can see whether somebody is listening or not.
Yeah, so it is no reaction back. And the result was that the Senate of Berlin, they said that it is not allowed to illuminate the garden. that was the only possibility. So, yeah. So, we have a lot of consequences. If you put something to zero, well, the rest of the Maxwell equations is very, very well accepted and is perfect, a perfect description of all effects which may be calculated by these equations. But what about those effects who are not calculated? Because you have reduced this theory.
Perhaps you could once more repeat for the cell phones, the mobile phones, that there is a kind of noise which is known but not really qualified.
Yeah, antenna noise it is. Yes, it's called antenna noise, and this these are vortices, potential vortices. If they decay, they are producing heat. Yeah, because we know this from eddy currents. If these vortices decay, they're producing heat, and
we feel it when we have a long cell phone call.
Yes,
it is getting warm.
Getting warm. Okay, the microwave oven is using this heat, but you see that this part is not explained by the Maxwell equations, because in the Maxwell equations heat does not exist in these equations. Yeah. So there is something in between the wave and the heat. In between there's the vortex. That means if these waves are absorbed means they roll up to a vortex maybe, and then you have these vortices. And if the vortices decay, so this is a thing in between, then you get the heat.
And if you say vortex, you actually mean two vortexes combined.
Yes, always combined, because you always have an expanding in the inside and a contracting from outside. It's just like a tornado, for instance, when you know that the velocity is important, how big this vortex system is. So if this vortex is running over the open sea, it's filled up with water, the velocity is changing, so the potential vortex is getting stronger, bigger, and it is more and more contracted. That means it is more and more dangerous.
And this is your detection, this potential vortex?
Yes, well, this is the parallel system for vortices in nature, as we know this, because these vortices were able to photograph and to make pictures.
But nobody gave a physical explanation for them.
Oh, I think these vortex systems are well known and well accepted. That because we know if it is running on land, it is raining, and so the velocity is changing again, and it's getting bigger, and at the end less dangerous. The energy of the whole system is constant over the whole system, over the whole effect, but it is changing in size. And if this energy is more contracted, it is the energy density is higher, and this is dangerous, and this is for us and for the buildings and for people and so on. Okay, if you compare this with the electric system, where I have developed these potential vortex, and I have described it in a mathematical way. Then we have again both systems, and we are able to describe these structures. And if you have a possibility to describe structures, then you are able to explain what flashlight is, what a ball, flash, and so on is. You are able to explain what electrical particles, electrons and other particles, protons, positrons, and so on, what they are, because today these particles are all postulated
in
quantum physics. Because quantum physics is not able to say where they are coming from. Coming from, I don't know. They postulate it. And if they have postulated a particle, they are not able to derive it from something else. And this is the problem quantum physics has, because they have everything postulated. Now they look for something they can put to this postulation, another postulation like quarks and gluons and so on. They try to postulate what they have postulated.
The postulation means
forget it.
It is an idea, because otherwise their theory can't work.
Yeah.
It's just fantasy.
It's fantasy, yeah. Yes. So this is what quantum physics is doing today. So they have no success.
And you don't need any postulation.
No postulation.
That's the first time in the world, isn't it?
Yes. Well, I started with postulating these potential vortices, but at the end, nowadays, I'm able to derive it from accepted equations. So I don't need any postulation for my whole theory.
And that is an indication that you are very close to reality, what's really happening.
Yes, because if you have accepted these assumptions I start with, then you have, and if I have no mistake in my derivation, then you have to accept the result, because it is only a result of what we have accepted. And this is why the potential vortex has to be accepted. So if there is somebody who says, no, I don't want it, I don't need it, whatever, he has no chance, because if he is accepting what I start with, if he is accepting with my derivation, because he is not able to find any mistake, he has to accept the results anyway. Well, then we have the possibility to discuss these results, because in mathematics sometimes we get results which have no dependence in physics, no reality in physics. Okay, we know this has to be proved, and this is why I started with the work of Tesla to reproduce this work, because Tesla has found things which are not explainable by the standard physics, especially these longitudinal waves. That means waves only in one direction, in contrary to the electromagnetic Hertz wave, which is transversal and from one center and in all directions. Yes, well, I derive as well the Laplace equation, which is the oldest description of waves.
18th century already.
Yes. It was a long time before Maxwell. Maxwell was a professor of mathematics, so the Laplace equation was part of his lessons. Mm-hmm. And the students of Maxwell had to learn about this equation, which is describing a field, something like a field, which is propagating in space and time, and the distribution, how it is distributed in space and time. This is what this equation, this important wave equation, is describing. The inhomogeneous equation. The homogeneous is the time particle is zero, but and the Laplace, the distribution in space is described by the Laplace operator. Well, this is what we learn still today. And if we divide this Laplace operator in two parts, like the rules of vector analysis allow, then we get two special descriptions. One is describing a transverse wave, which is the Hertzian wave, and the other part is, in mathematics it's called gradient divergence of a vector, of a field vector, and the divergence of a vector, maybe of the electric field vector, is a scalar. Has a scalar value, so has no direction at all. Something like electrons or electric charge carriers. And these scalar parts in a wave equation, because the gradient of a scalar again is a vector, so the wave has a direction. The wave, because you see there are a lot of information in internet where some scientists think that the scalar wave would have no direction. This is a contradict to the wave equation. I would say they have not understood the wave equation. Yes, there are a lot of so-called scientists. Yes, who do this mistake. Well, okay, this wave has a direction, but is transporting energy and impulse as a longitudinal wave. Like a sound wave. Exactly, like a sound wave. We have a lot of longitudinal waves which are describing just this part of the wave equation. This is the sound wave. Another one is the gravitational wave, or in the plasma wave. Langmuir has got the Nobel Prize for developing the longitudinal wave in a plasma. And this is exactly described by this part of the wave equation. So I looked for a pronunciation or for a name for this part of the equation, because the other one we know is the electromagnetic wave. Anyway, this is accepted. At that time, not. When Maxwell says this is electromagnetic wave, there had been a lot of enemies he had fighting against it, because they said electricity and magnetism are very different systems at that time, you see. You can't mix it up to an electromagnetic wave. What are you doing? So they said this expression is nonsense.
And today you are in a similar situation, because you are with something new.
Now it's a similar situation. I thought about the explanation as a scalar wave, and said, okay, this part is describing a scalar particle which is transporting or moving as a longitudinal wave, so this is a scalar wave. And this word is not new, it's not mine, but under all the possibilities I thought this is the best description. And this is why I call them scalar waves. And
how did Tesla call them?
Well, Tesla was an experimental physicist. He was not in theory, so he was always a bit uncertain. And did mistakes as well at this point, because he said that the Hertzian wave is wrong. It is a long wave, not a transverse wave, he said. So he has the right wave, and Hertz said, no, I have the right wave. So so this is typical, but not useful. What we need is a mathematical background, because the physics of today always has a mathematical background, and this has to be accepted. And Tesla, I think, was not able to see all the consequences.
Mm-hmm.
And but I come from field physics. I'm
you make your thesis in vortexes.
In vortex calculation and description. So this is my special field, and this is why I try to find out what the right one is. And the answer is both are right. Both are existing. Not only these two, we still have a third one, a third wave, which is not described in textbooks. So this is my wave, I would say. This is the magnetic wave, because Tesla was using the magnetic scalar wave, exactly. Tesla was using the electric scalar wave, which is propagating in the direction of the electric field pointer. Mine is propagating in the.
And he sent electricity without a wire. Is that?
Yes. And what he could do with the electric field, I can do with the magnetic as well. And I've shown that these magnetic scalar waves are specially used by human beings and by plants, so in nature. It is the most important.
We have to teach now, there are three kinds of waves. Yeah. The electromagnetic wave, which everybody knows, which is getting weaker when you get more and more distance. Mm-hmm. And then two new ones. Mm-hmm. Two kinds of scalar waves, the electric scalar wave and the magnetic scalar wave.
So it is, yes.
And the magnetic scalar wave you detected and printed the name for it.
Well, when I, at the end of the 1999, we could publish it, and we could show it to everybody here in Villingen in the technology park. I first tried to reproduce Tesla. Mm-hmm. One-to-one was not possible because I don't.
It was a huge tower.
A huge tower. I don't have the funds, and nobody who was giving me the money to reproduce it one-to-one. So we had to reduce the size. That means we have less of the wavelength. Less of the wavelength, but higher frequencies. And I skipped it to from long waves or even very long waves to short waves. Mm-hmm. Well, this is different anyway, but we were able to reproduce all the effects Tesla described in his writings.
And patent also.
In patents as well. That this wave is quicker than the speed of light, is not shieldable by anything, is transporting energy,
sending more in the effect, which
is maybe
what you send away. Sometimes
has an over unity effect, so has an efficiency of more than 100%. But this is dependent to the environmental conditions.
You reproduced what Tesla did in his days to show that he could send electric current without a wire.
Yes, we could reproduce all his findings. That these scalar waves, these longitudinal waves, have very special properties. They are not shieldable. They, by a Faraday cage, they are quicker than the speed of light. They are carrying energy. Maybe they still are able to, because it's an open system, collect energy from outside, from the environment.
Because there's more energy coming to the bulbs than he sent away. Usually you lose energy, but he won energy.
Yeah, that could be the consequence.
That they call over-unity.
The effect would be over-unity, an efficiency more than 100%. This is what the consequence would be.
And it's not a perpetuum mobile.
No, because it's an open system. It's using another source. Another source is necessary. We don't know where the source is if we have a over-unity. At Tesla's time, we had no transmitters on Earth. So when he was getting an over-unity effect, he said this energy is coming from the sun. Especially in his experiments in Colorado Springs, when he tried to find out all these properties.
1898, 99.
Yes, 99, that's it. 1899, yeah. And he was describing that he has got an over-unity effect of about 10, that means 1000% efficiency.
But not constantly dependent. Sometimes more, sometimes less.
Yes, yes. We have the same effects. With our experimental kit. When I showed this kit the first time, 99 it was, yes, at the end of 99. Some physicists, especially one, has tried to reproduce it, was unsuccessful, and then he wanted to publish it. He did it, but I said no. If you want, I invite you to do the measurements in my institute, in my transfer center. And he said no. He first wanted to publish that it is not working and that Tesla was an error, and my system is not working as well, and then I said no. When you've published it, you don't have the invitation is only before you publish it. So that was a problem. That if these engineers who try to reproduce it. Maybe 50% are successful, 50% are not successful. But it has nothing to do with the system. But at the end, everybody says, oh, it's not provable. We need a reproducibility. This is necessary in science. Anyway.
It's vital, yes.
Yeah, so one condition. And necessity condition. And this is why we said that we have to produce an experiment which shows always the same effects. And so in the year 2000 we started with this production of these demonstration kits, which is a small size, and then the experimental kit, which is the total size with all the possibilities, with different Tesla coils, because Tesla was using not the same coils at the transmitter and the receiver. He was using, nobody knows this, or only if you read his books, you see that he was using the second part of the half of the wavelength for the receiver, and a quarter of the wavelength for the transmitter. And this is why we have in our experimental kit, we have different sizes of Tesla coils with half of the wavelength, twice of the wavelength, and so on. So you are able to reproduce these original patents of Tesla and to get the same effects.
Very good, yeah.
So this experimental kit is only to reproduce Tesla. Some people say, why are you using an earthing line? Well, in Tesla's writings, you know that Tesla was always using the earthing. If you switch off the earthing, the received energy is zero. So it stops at once. This is what Tesla said. So if you want to reproduce Tesla, you have to reproduce just these effects one-to-one.
And he had patents on that also.
Yes. But they're very old, so this.
But you can still have access to them, and everybody can look at them.
Yeah, everybody is able to look at it, and so I don't want to give too many advices and to explain too much by my effects. I wanted that those who are interested in Tesla technology have a possibility to reproduce the original patents one-to-one, or well, in this other size, but the effects are the same. The principle is the same. And this is, well, you are able to transport energy wirelessly without wire, without grounding wire. This is possible, not with this device, but it is in principle it's possible. And this is not critics. I don't feel it as critics, because they always say we are critics. You see, they only are not able to read what my writing is and what my opinion is. You see, this has nothing to do with critics. Okay, but this experimental kit is quite successful because I have only positive results. Those who have bought it, who have used it, are all accepting it.
And it's universities all over the world.
Yes, universities and schools and a lot of engineers and physicists who are interested in this technology. Yeah, so all over the world. I'm still selling this from my institute, from company till today.
And it's quite cheap.
Yes, it's we don't want to earn money with this. Only the employees I have here. Some are students, some are working for me. They get their salary from this production. So there's nothing for me. I don't earn any cent from this. I don't want that. I don't need it, and I don't want it, because I'm professor and I'm paid by the state. But it's necessary as a support for my science, you see. And there it is really very important, very interesting, and a lot of people are doing it. So what we have done later is that we have tried to size up the power, so that we are not only to show with 50 milliwatt or 100 milliwatt very low power is enough for showing the effects, but if you want to use it for power transmission, then you need a bit more. That was when we started with these boat with 50 watt or 5 watt or 10 watt, and then we sized it up to about 500 watt. 400 watt, and we are moving motors and so on, and we have had this system in a laboratory for electromagnetic compatibility, EMC laboratory, and we're measuring the fields, because if you have a transmitter for 400 watt and there is a motor, a washing machine motor, moving, turning, they all thought we would have a lot of spreading fields, and they measured zero. They measured nothing. We have put the transmitter in a Faraday cage, so that no electromagnetic waves were coming out. And you know that an EMC laboratory is measuring only electromagnetic waves, so they measured zero, because they were captured in this Faraday cage, the electromagnetic wave, and only the scalar wave are coming out, and they were used by the motor. So there was no spreading field, nothing. So if you use this system in a right way, that means that you collect everything you're transmitting. You have no biological effect. And this is what we need. We need mobile phones who are using these scalar waves in an individual resonance, so that you have no biological effects.
Because what we today think is electrosmog, we think it's the Hertzian electromagnetic wave, but in reality it's not.
It's not.
It's the scalar part of this radiation, because this is only interfering with the body. The body doesn't care about electromagnetic waves.
Yeah. So it is.
So the solution would be to have a mobile phone system only on scalar waves, and that means they are not spilling over and damaging, but going directly, and then nobody is harmed.
Well, one effect is that the mobile phones need no battery, because they get the energy wirelessly. Another effect is if you have a special resonance, it is individual point-to-point connection. Because if I phone to somebody, I only want to phone with this one person and not with the rest of the world. Today, we have these spreading fields. They go everywhere. They go in every sleeping room, and they are not allowed to do this.
And the Secret Services are eavesdropping.
So this is a real problem, because today we are using the wrong wave for mobile phoning, only because we have put the other one to zero. We don't understand it. We have no education on this field. You see, what is the education? It's very special. We have a special education for high-frequency engineers, which learn how to reduce the noise, that means the scalar waves, how to reduce the noise, that the signals may be detectable. Only if the noise is reduced. They do everything. They are using shielding wires. They are using 50 ohms impedance, so that the connection is perfect, is reducing these antenna noise maximum, and this is what they learn. That means noise, and by this the scalar wave part of an antenna, for a high frequency engineer of today is waste. And what I am doing is that I explain that it's just the opposite.
You need to take the waste.
The waste is the best. And what they are using is waste. You see, the technology of today is using the electromagnetic wave, which is propagating at a constant speed of light. And the speed of light is, if you multiply the wavelength with the frequency. So that is connected. If you modulate, because you need to modulate music and pictures and so on such a carrier wave, if you transported the information to your radio and to your television device, to see the pictures, you need to modulate it, to carry it with a carrier wave, which is like a lorry carrying from one point to the other what the customer needs. And if you are modulating your signals to the frequency, FM maybe, then you have modulated the wavelengths at the same time, because
the light speed is constant.
Both are connected to the speed of light, which is constant. So this is a problem, because if you have a lot of information, a picture for instance, then you need to transport pixel after pixel and line after line. So this is how our computers are working, how the pictures in our television is produced, and so on. But this is a very, very bad and very primitive technology. It's only the only one we have learned, and what at universities the students learn. But the scalar wave has no constant speed. That means you have one dimension in addition to modulate.
Because you either can modulate the frequency or the wavelength.
That's it. That means we have one...
That's fantastic.
And because we have one dimension in addition, we have not 1,000 times, not million times more for modulation. This is a whole dimension. Or with other words, but this is what the nature is using. Because if you remember a picture from yesterday or from this morning at breakfast, you remember this picture instantly, not pixel by pixel and line by line. So this is a parallel signal processing, whereas our technology is a serial, and we know that the serial is slower and in words is not comparable. Mm-hmm. The parallel is much better, and this is why the human being is using a parallel signal processing, picture processing, and so on, and they are much more effective. We have a CPU frequency of 10 hertz. Our computers are using gigahertz and are not as successful as we are.
Getting warmer and warmer.
Yeah.
We don't need that.
We don't need that. Mm-hmm. We don't need this cooling system for our brain here, such a cooling system.
When I started to make a research on the scalar waves and found your research, I thought there's an electromagnetic wave, there is a scalar wave. Now we know there are two kinds of scalar waves, so it is either. But you say when an electromagnetic wave is broadcasted, it is always connected to a scalar wave. How do we have to understand this? Because you said that there are parts always which are scalar wave, or other part electromagnetic wave. It could be more or less. But they are always kind of connected, and when they swap, there is no energy needed.
Well, we know about the near field and the far field, and there is some in between in the transition. But we separate between this near field and the far field. What happens if you have an antenna is that in the near field, at the antenna, you are only producing scalar waves, 100%. Because we know these pictures where these fields are coming off from the antenna, from the dipole. Yes, I have it in my books. For instance, in the book of scalar wave transponder, because I'm explaining these technology here. Here you see these coming off of the fields from a dipole.
School books.
This is from a school book. Yeah, I have it from the school book we were using when I had been at school from Grimsel. Grimsel is a very important school book.
I had it in my school as well.
Mm-hmm. And well, this picture is well known in all the school books because it's explaining, as you see, how these vortices are forming, and that the next vortex is pushing the last one, and so this pushing wave is like the sound wave when one air particle is pushing the next, and they're transporting it as a longitudinal wave. Mm-hmm. And this is just the same. And we have this situation in the near field of an antenna. Mm-hmm. And especially if we look at the antenna exactly where this dipole is showing that the fields are running from plus to minus, and if the charge carriers are moving in the dipole, then they are producing a magnetic field, and then we have the opposite polarity. And you see that we have 90-degree between the electric and the magnetic fields. 90-degree. In the electromagnetic waves, it is zero. We have it here in this picture that when the electric field is zero, the magnetic one is zero as well. So we have a phase angle of 0 degree at the electromagnetic wave and 90 degree at the scalar wave. Mm-hmm. So this means that we are able to detect exactly what it is if we measure a wave. We can say this is a scalar wave or this is an electromagnetic wave. What happens at the antenna? If I'm transmitting such a wave, up to the wave equation, we have these two parts. At the beginning we have 100% scalar waves in the near field, and well, in this transition some things happens. We don't know exactly what happens because we have a mixture, and in the far field, that is, if the distance is more than the wavelengths divided to 2p, that means a sixth part of the wavelengths, then it stops, and from that point on we have the far field. We say in the far field we have a mixture of electromagnetic waves. If it is a good antenna, we have perhaps 80 or 90% electromagnetic waves, and the rest are still remain vortices, but these vortices are not stable.
But the majority of the people still think we are only transmitting electromagnetic waves.
Yes, because our devices are only looking at these waves, and only these are described by the Maxwell equations. Mm-hmm. Okay, but the Maxwell equations do not describe the near field, so this is a problem. And what in the textbooks is done is that they postulate vortices around the antenna, and then they are describing what they have postulated. Forget it, you see. But, well, the result is correct, is exactly what they measure, but it is postulated. I don't need this postulation, because I'm describing it with my extended field theory, and I get exactly what they measure.
And in reality, you found the unified field theory,
yes,
which everybody looked for since centuries.
Yeah. Okay, there are a lot of things which are in addition coming to that. But let me explain what happens with this wave. I transmit it. It is changing to an electromagnetic wave. Parts are decaying, vortices, they are decaying, they are producing heat. We call this antenna noise, at the end, antenna losses. Mm-hmm. And only this part which is transmitting from the transmitter to the receiver, mm-hmm. is the electromagnetic wave. And what happens at the antenna at the receiver side? Then this electromagnetic wave is rolling up to a vortex, because it's reflected at the end of the dipole, is running back, is reflected again, and so on, and is producing a vortex. And so
switching over to scalar wave.
We can say this vortex is part of a scalar wave. So this is it is a standing wave, the scientist says, and this standing wave is because it is reflected, is always getting more and more. You see, the more often it is reflected, and thereby by this the part of the energy is reproduced and is moving the electric charge carriers in the antenna, and these may be detected by my receiver and amplified and so on, and at the end I am able to hear music, which is modulated on this wave. So this is how our system is working, and if there is part of the transmitted energy of the transmitted wave, if part of it from the near field remains a scalar wave and is receiving the receiver as a scalar wave,
it's quicker.
Yes, it's quicker, so effects like fading and so on, we know that these exist, but they are carrying the same information, the same music, and I'm able to use the scalar wave as well. I don't need the electromagnetic wave, you see. So we have two possibilities, yes, but the scalar wave, as you say, has to be quicker than the speed of light, otherwise it would decay and would produce heat.
And that means you can even revolutionize radio technology and television technology.
Yeah.
Using scalar waves.
Yeah, using
and
scalar waves.
You make the parallel technology, and the quality of the picture is perfect, no pixels are missing.
Yeah, yeah. So this is a very new, totally new
and you
technology.
can count how many visitors you have, how many spectators you have, because you can see who is receiving and not.
Yeah, yeah, yeah. I'm able to count them.
Yeah.
From as a radio station using the transmitter. Yeah. Mm-hmm.
Mm-hmm. Revolutionary.
Yeah. So it's a different system. We have with these plasma TVs, we have developments in this direction of today, because they need to use more dimensional support for producing these high definition pictures, and they have so many pixels, and you need new technologies for supporting them. So the television technology of today is just stepping in my direction.
Interesting.
Still, nobody knows, because they are all looking in these flat TVs, but they don't know the technology in the background. But I know that this technology, because I have contacts here to Thomson in Villingen, which has been Saba TV before, a very famous television producer here in the Black Forest. And so I know that what they are doing a bit, and I think they are going in this direction. They need to go. They have no other chance.
And your next step in your research was what?
Well, these books are totally new, you see. These 4 parts. I started 20 years ago with only the 2 parts. The first describing these vortex.
The potential vortex.
The potential vortex. I have a paper, a peer-reviewed paper about these vortex problems, which will be printed this year. It will be open published, so you can see it in the internet.
Who's printing it?
That is Ashton Publishing House. They have asked me, and I'm editor-in-chief.
Oh, congratulations.
So yeah, thank you. And this will be the first paper, because I want to start this Journal of Vortex Science and Technology, which is the name. I want to start this journal with a paper describing what the vortex problems are. So this is part of this first book. It's in English, so this is first what we have translated. And this book is a new edition of the one from 1990, and the proof that my approach is correct was at that time that I had been able to derive the Schrödinger equation, which is the basic equation for chemistry and the basic equation for quantum physics of today. And this equation never had been derived before, because it was impossible to derive it from Maxwell equations. But from the extended equation, it is possible.
And one can say the Maxwell equation is a special part of your equation.
Yeah.
It's not contradicting, but it's a special part because they put that to 0.
Yeah. You see, the Maxwell equation has one problem, that it has no possibility to form a structure. And we have the structure. The Schrödinger equation is describing structures in the hull of an atom. And if you have put this part to 0, you have no chance. You see, this is what physics of today, the problem is for them. And I have solved this problem with the potential vortex. I'm able to derive this equation. And at the end, I'm able to explain it, you see. If I derive equation from others, I know what the meaning of this equation is. You see, the physics of today have no idea about what the the meaning of the results of the Schrödinger equation is. And what they say is that it is somehow, while the electron sometimes is over there or there, it is Aufenthaltswahrscheinlichkeitsdichte. I don't know the English word. It's
the probability of the location.
Of the location, yes. So this is how they explain it, because they have no rule where these equations is coming from, and if you have no basic, you have no chance to explain what this is describing.
Yeah, and we learned that light wave could be both particle or a waveform.
Yeah.
And I always thought as a pupil that then they haven't grasped it. There must be something wrong if they.
Yeah, well, you see, this has to do with this edict of Copenhagen, with when Niels Bohr was at this point, at this problem. He said, we have the problem that some are able to detect the light as a particle and other as a wave. Fraunhofer lines and so on, and on the other side, those who see that these are particles. So both have had a reality. And well, what I say is, you know, that they had were fighting against, and that some were leaving the conference and were shouting and said, I have a proof, and they ignore it, and the other said, I have a proof, and at the end there were remaining guys like Einstein, who was field physicist in his heart, but has got the Nobel Prize for his hypothesis, light quantum, so this is a quantum, and one has nothing to do with the other, and so he was remaining, has no idea, and Heisenberg said, okay, then we explain it as with a compromise. So it's up to you how you look correctly or not at this, and then you see the particle or the wave. Forget it. It's a compromise. What is the reality? What I always say is, if we have an equation like the wave equation, which is explaining that we have scalar waves which are describing particles, and if we have on the other side in the same equation electromagnetic waves which have no particle in it and necessary, then this equation is explaining this 100%. There had been scientists in one conference, and nobody has knowledge about the wave equation of Laplace, which was well known at that time. I don't understand this. Heisenberg, why was he coming with this compromise? If he would have heard about the wave equation, this compromise was not necessary. You have to, if you have rules in physics, you have to accept them. You have no freedom to say, today is Sunday or Monday, and today we are using the one equation and tomorrow the other one. This freedom you don't have. We have rules always because we want that these rules have to be accepted. If we have found out that these rules are correct, okay, this has to be proved first.
So simply spoken, light consists both of particles and waves.
That's it. Because the wave equation has no other answer. That means it is up to the one who is detecting
what kind
the
of
wave.
measure instrument you do?
Let me explain this. It's interesting because if you have detection like Fraunhofer with his comb, where he was sending the light in a comb, and at the end he was seeing only waves, only interferences of waves. So this is, if the light would have been, part of the light would have been particles before, at this comb these vortices are rolling up to a wave, cracking to a wave, and you see only waves. And the opposite experiment, if you have a camera under high pressure, then you see when the light is coming in, it is rolled up because of the high pressure. It's rolled up to vortices, and you see the particles as a line. You are able to make photos of these lines, and you see that they have all properties of a line because they are now scalar waves. And but they have not been before. It is our measurement device which allows us to see the one or the other thing. A practical example is your eye. Our the light from the sun is coming as an electromagnetic wave, and this electromagnetic wave is changing the first time when it's coming into the atmosphere. So part of these electromagnetic waves are rolling up to vortices and are running as a particle. They start at the sun as photons, 100%, like an antenna, 100% scalar waves. Then in the far field, that means in the space in between sun and earth, they change into electromagnetic waves. We have electromagnetic waves because electromagnetic wave you are able to send through a vacuum. You don't need any particle. But in the atmosphere, the first time, part of them are rolling up to particles again, to photons. And if you have a window, you have the same light outside than inside, but it has changed in the properties because running through the window, the glass, the electromagnetic waves are changing into photons. So you don't get brown if you sit behind a window, but if you are in the sun, you
different quality of the sunlight.
It has a different quality. Yes. And this is what we know and what we are able to see, but it is the same. The window, the glass is is not breaking the light. It is as lighted behind. If this light is reaching your eye, we know that inside the eye we have a high pressure. If there is no pressure, we see nothing. We are blind. Mm-hmm. That means these Stäbchen und Zäpfchen. What is it? It is yes. This is special.
Small sticks in the eye,
sticks,
and the opposite, which we have at night and on daytime.
Yeah, no. Well, these sticks are the detecting device we have for the light. We know. But these sticks are no antennas for electromagnetic waves. We are not able to detect any electromagnetic wave. So we have to change 100% into vortices. And the vortex is detected because the vortex is running on the stick and then is transported by the nerve to the brain. So this is a chamber under high pressure. It's just the same. We know we are able in this chamber to detect photons, and this is what we are using. So this is used any day.
Because of time, what was the next step in your research?
Well, I always looked at all the effects at the same time, and my scientific work is like a screw moving, you see.
Like a vortex.
Like a vortex, yeah. But slowly I get forward. So this is always the same. And now I said I have to renew my scientific books because first I started only with the idea that I wrote wrote these books, which are a collection of material. I have it in English as under the title Scalar Waves, as one book. But these books all show the slides on one side and the description on the other is for the students and for seminars and so on, as a material for for the listeners, and as well to discuss all these problems. So this was my material collection, very important for me, because I'm able to jump, and the reader as well is able to jump from one point to the other. This is really a collection, so with a lot of ideas, and I have the other things as well inside, the derivation from textbook equations of my field theory and of world equation I get, which is a fundamental equation. Which is the basis for a lot of other things like Schrödinger equation and so on. And everything is inside here, but not well collected. It is just like my ideas came. I started with the first, then I wrote the second. The second is about the energy part and the energy.
But now you condensed it.
And the last one is yes, and the last one is information. Well, I condensed it now. I said, now what I have to do is that I have to do the opposite, not collecting everything, but reducing to minimum to what the essence of my theory is, and this is why I renewed the old books. And I gave them a new title. In English, this would be about vortex physics, from vortex physics to the world equation. This is the first part. But it still has these derivation of these Schrödinger equation inside. And then on the way on, I had problems with the theory of relativity, because this Einstein, this important theory has a problem because it is using the speed of light is constant. We know that in matter the speed is reduced. Perhaps in glass we have only part of the speed. And today we have a lot of scientists who start a race to start up to make the speed of light quicker or to reduce it. They reduced it down to 65 kilometers per hour. So this is in an Einstein-Bose condensate. This is one effect, and on the other side they try to reach hundreds of the speed of light, you see. And well, we know that in textbooks it's not allowed, but they do it, you see.
Yes, CERN did it last autumn in 2011, but now they renounced it very mysteriously.
Yeah, well, this is coming up, and then it's then
they get pressure.
Colleagues, yes, of theoretical physics, they do not accept, and they say this is nonsense, and they think that the nature would do what they describe, but it's just the opposite, you see. They have to learn it. It's a long way. Okay. Well, the theory of relativity is important and is from the starting point it is correct anyway, but it is no theory for everything, because it is only an observable theory. Is what we are observing, what we see. You see, this is very special, and it is not enough to describe the particles. And well, with the potential vortex, because all the books have this title, potential vortex, part 1 and part 2 and so on. These potential vortex gives the opportunity to describe and to derive the particles in physics, because these particles have a special form, a special size, and so on. And this potential vortex is the structure-forming effect we need to derive these things. And this, the theory of relativity was blocking this, absolutely. And I worked 2 years from 1990 to 1992 till I had been successful, and I found out that I have to, as an observer, I have to be outside of the system. I don't have to be part of it, because if the speed of light would change, you have no possibility to observe it, because you look with the speed of light. Mm-hmm. And if you detect everything with the speed of light, you come to the solution like Einstein, who says, only what I'm able to observe is my reality, and the rest I ignore. Mm-hmm. But if you want to derive particles, you can't ignore it. And this is why I needed another transformation. The Lorentz transformation was not enough with the constant speed of light. And this was why I started with the theory of objectivity. It was necessary, and it's very successful.
Principally, it is that Einstein is going on this mainstream saying, oh, what we can detect with our body is not existing.
Yeah. Yeah.
And you say, well, there could be something else, yeah, which we are not able to detect with our body, yeah, and therefore you call it objectivity theory.
Yeah. The problem I have is that I'm not able to observe it. So I have to use a mathematical way. What I'm doing is I'm using the theory of relativity to describe something. And then I transform it to, in the world of objectivity, which is only described in mathematics. And then I'm able to calculate and derive everything. And the result I have to transform back into our observable world of relativity, and to compare the result with the measured effects. And on this way, I'm able to derive very old postulated laws in physics, like
Is it possible to say that the relativity theory from Einstein is a special part again of your objectivity?
Yes,
theory?
because
but only a special part.
Only a special part. It is. This is what you can say, well, behind these theories, you have transformation theories, how to transform if one system is observed from another one. We have to transform the system. So this is what Galilei did under the situation and consequence that the speed of light is infinite. So he ignores this. This is in his history. It's a transformation of Galilei, and the theory is only subjective theory, like Newton's mechanical theory. Mm-hmm. And then Lorentz came with the Lorentz transformation under the condition that the speed of light is not infinite, is constant, but has a special value, 300,000 kilometers per second. So under this condition, he gave the transformation, and Einstein gave the theory behind. And the consequences, describing the consequences. So if there's a length contraction, and that means the meter is changing, and the speed of light is meter per second. If the meter is changing, then the seconds have to change as well. So the clocks are going wrong. So this is the consequence of the theory of relativity. And I always say, pay attention, this theory in the starting point is correct, but not in the consequences if you are using this theory for everything.
If you want to make it objective.
You can't make such a theory objective. It's impossible. So what I did is that I said, no, we have to accept that the speed of light is not constant. It has a special value anyway.
Robert has always said it. He said thoughts are quicker than light.
Yeah,
because they are scalable.
Could be quicker or less. Everything is possible, and you have to renew the transformation of Lorentz under these conditions, and then you come to my theory. Okay, this is only to describe this. You have everything inside this book. This book is more in physics, you see, because in philosophy, because the basics for all this, at the end you end at the question, what is the field? What?
But 1 second. This is the unified field theory.
Yeah.
And that is genius.
Yeah, okay.
Because everybody looked for it. And,
yeah, for a long time. Yeah. And here you have it. The title says, From Objectivity to the Unified Theory, or Theory of Everything, you see. So this is really all the interactions, everything under one theory. Yeah. So this second part, well, it's from 1992. And there's only a few parts are new, but the main idea is 20 years old. So after 20 years, I said, now I need this.
And with this you solve the old quarrel in physics, is there an ether or not?
Yes, has to do with it, because the equations, the main equations I have on the cover here. This is the unipolar induction, which is describing that E, the electric field, and the magnetic field here, the induction B, are connected by a special speed, whatever the speed is. You can explain as the following: if you have a magnetic field, like the field of the Earth, magnetic field of the Earth, and if you sit in an airplane or in a rocket, and you are moving perpendicular to the direction of the magnetic field, and you have your measurement devices with you, you are able to detect, oh, there's an electric field. There's an electric field if I'm moving perpendicular to the magnetic field and perpendicular to the movement direction of the propagation. You have the electric field in that direction. So this is what Faraday has found out with his Faraday generator. He has shown that this is correct. This is the law of induction, a special description which is called unipolar induction. But there is still a quarrel in the textbooks whether this equation is more important than the one of Maxwell or less important, because Maxwell has the same description in another way. He is describing as well between the electric field part or in the magnetic induction, but in another way. Mm-hmm. And the question is, which one is the more general equation and which is the special part? And today, in textbooks, well, the majority says that Maxwell's equation is the most important, and this is a special case. But there are some others who say the opposite, like Pohl and Bosse, and they derive it, and I too do the same. I derive the Maxwell equation, or even extended equation I need from this one. So this is the starting point, and this is the most important equation. And this equation says that we have two sides of a metal, which is the electric and the magnetic field. And one is changing to the other one if there is a movement. So, if you have an ether, and you know that Michelson and Morley, they tried to find out the ether wind, because Maxwell, it was an idea of Maxwell, originally. Maxwell says, I want to prove my theory. And at the end, this experiment was negative. So Maxwell said, no, don't give this experiment my name. Use it, Morley and others, everybody is able to use it, because it was just the opposite. He wanted to prove his theory, and the opposite was
they
didn't found any. Here you have the answer, because if you have an electric field, the field is the influence for the light, and the influence for the light, the cause for the known value of the speed of light was called the ether. And this was at the beginning, and that Maxwell said, I'm able to calculate this, and by my equations I get 300,000 kilometers per second. And I want to know why this speed exists. I want to know the cause. This was why he went to Berlin, to Potsdam, and they did this experiment, because at that time Michelson was a volunteer in Potsdam, and he did this job here in Germany. So that was negative. Now we know this, because if there is an electric field which is influenced the speed of light anyway, and if we are moving with the Earth around, we are turning around the Sun, we are moving, and the Sun is moving, everything is moving. If we have a movement, we, as a result, get from this electric field a magnetic field, and vice versa. And a magnetic field is getting an electric field. So, if you have an ether, which is the electric and magnetic field, and if you are moving in this field, you detect a non-moving ether with electric and magnetic field, but they have changed their position. From the magnetic, electric it is coming, and from the electric one is getting a magnetic field. So
a little bit like a hot, warm air balloon, where you don't feel the wind because you're moving.
Yeah, well, if I'm moving with the wind. But you see, this is the only description which is explaining exactly why they could not measure any ether wind. But you know about these experiments from Bradley, who has shown that if he is observing other bodies in the sky, he is able to see this effect, which is not detectable on the Earth for a laboratory scientist who is measuring here. You see the problem. This is, well, at the end, more than physics, it's philosophy.
But one can say you prove the ether here. And what is very fascinating, you say there could be material, there's always needed to be material with ether, but the other way around is not. It is possible ether without material.
Yes, because ether, in my opinion, is the field, and the field is able to exist without matter, because I'm able to get shine a light through the vacuum, where there's no particle.
And that corresponds with the esoteric people saying it's always the thought first, and then material is coming.
Yes, if we look at this rule, which has been the first, always the field needs to be the first, and then the matter. So the matter, well, this is the old fight between field physics and quantum physics, which is the original effect. Is the field, because you know till Max Planck started with his quantum effects and was developing them, we only have had field physics. The field was everything, and the field was first, and so on. But then, because the field physics was putting this structure-forming particle potential vortex to zero. They have not been able to describe the particles, and this was the main mistake the field physicists did.
It was crucial.
Yes, and the result was that others, like Max Planck and so on, were detecting these quantum effects, with a consequence that he said, if you, field physics, are not able to describe what I have found, we don't need you. And then they started with the quantum physics, and they tried to explain all the effects as quantum effects, all the field effects, like gravitational force. They said we need gravitons and so on, and hypotheses everywhere. And this is what they do today, still today.
But they can't explain it really.
Yes, they can't explain, because they have postulated what they want to explain. It's impossible. But you see this problem. And I said, if I now add this potential vortex in the field physics, then I'm able to describe it. But the result is, I have it in my first book, that if the Schrödinger equation is derivable from these extended field theory, then all these particles which the Schrödinger equation is describing have to be vortex structures. And this is why I wrote this third book about field vortices to the physics of the elementary particles. This is the title. So from these field vortices, which are forming by this potential vortex with pressure from all directions from space, so the only structure which can stand and can be stable is the ball. This is why they have the size of a ball and so on. And these balls, as a vortex ball rolled up, which is moving inside anyway, has a spin and so on. And but it is a vortex, field vortex, running around one point, which is the center of the vortex. And you know that the center of the vortex, there is no wind. We know.
It's calm, yes.
And here we have a speed of light which is zero. So this, because the speed of the light is up to the field. The bigger the field is, the less the speed is, the less. This is what we know, because we can produce field lenses to reduce the speed of the light. And so if the field lines all go to the center, the field is infinite at the center, wherever it is. And that means that the speed is zero. And this is why these balls are becoming a stable matter, which is at one place is stable, you see.
Because the speed is zero.
Because the speed is zero. But only these balls have this property. An electromagnetic wave don't have. But this is only a rolled-up electromagnetic wave, nothing else. So the whole matter, what we call matter, are all vortex balls.
That corresponds with others who say all the universum is a hologram.
You can call it a hologram, yeah. So this is here the proton on the cover with consisting of two positrons. Positrons are antimatter, and an electron is capturing it inside. Inside the electron we have these positrons, and so 2 times plus, 1 time minus. If you look at the distribution of these fields, you find out that at the curvature of this particle, there is no field. You know that we have the problem that if we have protons in the core of the element, they have the same charge. And if I have like charged particles, they destroy themselves. And this is why we have a real difference between, a big difference between theory and practical praxis and what they measure. So this difference was a problem, and physics say, okay, then we postulate a strong interaction which is fulfilling this or this difference. Yeah.
It's only postulated.
It's only postulated. Yeah. I don't need it, because if I calculate this field of this particle, I find out that there is no field. It is zero at the curvature. So I can put them one to the next, and they agree. Well, it's a bit difficult because they are turning. They have to turn that there is no crash. You see. So this turning means that only special points are able to fit together. And sometimes I need neutrons to optimize this. And so first of all, I try to calculate all the particles. And well, these calculation is perfect, because I have to find this.
Yeah, it's really amazing.
Yeah.
To see.
Yeah. Here I have the result between measured and calculated, and you see that all the particles we know from muon, pion, and so on. All these particles nearly give the same effect or give the same result between measuring and. But what really is a proof is that if there is a jump from one to the next, and if there is no particle in between, then we are not able to calculate any particle in between, and they have not measured anything. That means all the measured results I could calculate. They're corresponding exactly. So this is really...
It's convincing, yes.
Yeah, it's really a proof, it is. And at the end, I was only calculating these structures which I said are able to exist. And I didn't know what properties I could only calculate them and could say, okay, they have that spin and that charge and that mass and so on. Could calculate all these properties, and then I looked up in a table and I found them. You see, and everything they exactly were corresponding. Fantastic. So this was 100%, and quantum physics, they dream about that, something.
So they can close their shop.
Yeah, we don't need them. Because if you are able to calculate these particles, you don't need this machine for millions and billions of euro. It's not necessary, and we don't need all these physicists. They can do something else, because you can calculate it on at your table, and you don't need a big computer. You can do it by hand. So it's very simple, because you have only these vortices, and you have to calculate these vortices, how they fit together, and very simple.
For me, you are a genius.
No, it's just only if you do something correct and then you're successful.
Looking for the solution.
Yeah, then you're successful at it. So then, well, at that time, when I calculated these elementary particles the first time, I wanted to calculate the cause of the elements and then the hull. That means the whole atom. Mm-hmm. That was the next. The atom, then the chemistry, and so on. So at the end, well, if I'm able to calculate this successful, that means I need only the proton, the neutron, and the electron. So only a few particles, maybe not the neutrino as well for the explaining the decay. Then with these results, I should be possible to calculate the rest as well. So
up to the human body, the biological computer.
Yeah. So this is why I started to write this year, very new, this fourth part.
What's the title?
About core physics of the core and fusion to nanotechnology. So this is beginning from the core, then the whole atom physics, well, in this book I try to calculate all this. I have stopped in that year 1992 because at that time I've got a prize from the German electromagnetic environmental compatibility technology group, EMC technology was the name, and I've got a prize for my first books, and this is why I started first where I had success. This is normal, because if you have success in EMC, then you start with EMC. And today I'm successful describing the DNA as a magnetic wave, scalar wave. So it's clear that I go to the world conferences and explain this and publish it peer-reviewed on DNA, because those who like my theory, who need it perhaps for their scientific work, these are my friends. Yeah, the others, I can't wait till they are still fighting, you see, for the electrodynamics.
Because people in biology don't know so much about the fights in physics.
Yes, because they say in physics they have other themes, and they don't care about the DNA because it's not their subject. They are discussing what the complex epsilon, or which is the conflict to the constant speed of light, and all these problems. Yes, this is what they discuss, and what the magnetic monopoles they have found out and developed. What these consequences are. So this is what they discuss. It's very different. My theory is influencing all parts of science. Still history. Everything is influenced.
So brilliant.
Yeah. Okay. Let's speak about the equation you find on this book. Mm-hmm. There is an equation which is well known, that the electric or the magnetic field, is perpendicular to...
What means perpendicular for easy word?
No. Proportional, sorry. Proportional is proportional. Electric or magnetic field points are proportional to 1 divided to square of the distance. This is a very, very old equation or rule, which is so old that it has no name. Not the name of the developer. Normally, you know that the rule is called up to Heinrich Hertz because of the Hertzian wave and so on. But here we have no name. This is the law of the square of the distance.
Perhaps which we know from radio waves.
Yes. We very well know. This is a very well accepted equation that can be explained very simple. It is so simple that they know about this equation in former times, in ancient times. The Greek knew about it. Mm-hmm. If you have a source, and if this source is maybe a source of light, or a source of electromagnetic waves, radiations, and so on, then this fields spreading off from the source are at the same time on the curvature of a ball. So later the ball is getting bigger and bigger, and the curvature is getting more and more. And the curvature is 4p radius square of the radius. This is the curvature. And that means with the square of the radius, the field lines are distributed about this square of the radius.
Why is it the size of a ball?
Yeah, because it takes the same time to get to every point of this ball. And so you are able to distribute these field lines on this on the surface, and if the surface is getting bigger, then it is with the square of
pebble in the pond.
So it is. So we know about this law, and we have accepted it because it's only
it's easy to detect.
Easy to detect, and it is easy to explain. It is trigonometry. It is, isn't it? In mathematics. If we have accepted this rule, that there is an influence between the distance and the field, we have to accept the same rule if we look at the rule from the opposite side, from the other side. That
objective.
Yes. So this is what I do not allow to the physicists, that they say that this law is only acceptable in one way, to be read in one way. You have to read it as well in the opposite way. That means that the field tells us was the meter is. You see, there is these proportion that if the field is changing, this may be the reaction because of the distance to the center, to the source, is getting bigger. But we can say on the opposite. If we don't know where the source is, the size, that means what is 1 meter, is up to the field. What does this mean? If the field, well, the field is our ether, yeah, I told you. If the field is telling us what 1 meter is, then the field is as well the cause for meter per second, which is the speed. Then the field is as well the cause for the speed of light. Let's give us an example. We have a star that is shining, we see the light, we want to detect the light in our measurement device. And we know that the star, the light has the speed of light, but the star itself is moving with, let me say, half of the speed of light. If the star is moving away from us, then we have the speed of light minus half of the speed of light would be half of the speed of light. This is what we would have to This is what we would have to detect. Half of the speed of light up to the rule of Galilei transformation. But what we detect is speed of light. If the star is moving in our direction, we would have 1.5 times the speed of light. But we detect the speed of light. What is the problem? The problem is if you have the same effect in a train and you go through the row in one direction with 5 kilometers per hour and the train has 100, then you have 105 compared to the environment, the outside. And if you go the other direction, you have 95. So you know that this rule found by Galilei is correct. But in this, for the light, it's not correct. The problem is what is detect it. It's a problem of the engineer who is detecting the light. He is detecting the light by the field of his environment. That means if the light is quicker or less, his device would change as well. He is measuring his device. Yeah? Because only if the field would change, then the device would grow, but the speed of light would grow in the same way, because meter and meter per second are changing in the same way. Then you are measuring your measurement device. So 300,000 kilometers per second is the speed of light. Is only because we are telling what 1 meter and what 1 second is. So this is because of our definition. We don't measure the light from the sun. We are measuring our measurement device. So this is the problem. The speed of light is not a constant in nature. It is a constant in measurement. Well, if we look at it, we don't see it because we look at with the speed of light, and we don't see it. If we are using a measurement device, that means a meter, we measure 1 meter, because if the one is changing, the other one is changing as well. So we have a very different view, and if we look at the particles, we know that if a neutron is decaying, it is decaying into a proton and electron, and the electron is bigger than the neutron had been before. So how is this big electron coming from this small neutron? Because the field inside the neutron is much higher and is reducing the size of the whole electron, and then it's fitting. It's perfect. You see, this equation, this rule, is so fundamental, and physicists of today are ignoring it. This is the problem. We don't need laws if we don't accept them. Or if we say this law has sub-laws which are explaining this law only is true for this point and for this point. In your field, you know that they are doing this here and here. So you have a long list where this rule is correct and where it is not correct. Forget it. In physics, we have a rule, and then we have to accept it. We have to use it. Anyway. And I give you another example. Well, I calculate the whole particles.
It's proven wrong, but nobody proved it wrong.
Yeah. Here I give you a lot of examples. The whole book is full of these descriptions. I give you some more examples. I calculate under these conditions. I calculate the whole cores. Here the core of the helium and so on, and here all these particles. I still get the right size if I calculate the core of an atom here of Schwefel,
sulfur,
silicium, and so on. I still get the right size. That means calcium and magnesium, I get the right size. So this is perfect. Next is that I try to calculate the radius of the whole atom. And we have this effect. The bigger the atom is, the more protons and electrons and neutrons it has, the smaller it gets. It's unknown in physics why this happens.
They know that it happens?
Yes, they are able to measure it, and they know that there is a jump if there is a new orbit coming in addition, then okay, we have this jump, but then it starts with very big size and is getting smaller and smaller the more elementary particle it has. Well, this is not
paradox.
It's paradox, yes. But now we know, because the more particles I have, the stronger the fields are, because one is reducing the other. And if they are all together, one particle is reducing the other particle, and so the more particles I have in an atom, the smaller it gets, because of the fields. And I'm able to calculate. The calculation is here on 2 pages, okay, but you can put in this equation, here is the equation, you can put in these points and you get exactly what they have measured. And I proved it by this here, by the ions. Because if you put some electrons to it or leave it, then it gets much bigger or much less and is changing the size. And still these ions are able to be calculated by the same equation, and you get the correct values.
And so it fits what the experiments already have shown.
Yes. So this book shows that this rule I use in the other books as well. I derive it from these theory of objectivity. So I always get back to this rule. This rule is really fundamental. And I give you another example, which is very important. If the Earth is well, let me say the Earth is passing the Sun, the solar system. It says, "Hello, Sun, nice to see you, and I have no time. Sorry to say goodbye, and I want to go straight on." No problem, no chance to go straight on, because the Earth is in the field of the Sun, and if the Earth has reached the field of the Sun, something happens with the speed. The sunny side on daytime is nearer to the sun than at nighttime. That means at daytime the speed in meter per second is less than on nighttime. And if the speed on daytime is less than on nighttime,
the speed from the Earth,
not turning but moving through space, then if the speed on the nighttime is more, then the Earth is moving around the Sun. That means
it's not gravity.
Thank you, because there is no gravity. It's only the influence of the field of the Sun to the speed of the Earth. So gravity is only
a vehicle.
Vehicle, yes, a helpful description. No more. Well, we can use it. We can use it, and we feel these forces. Okay, but there is no force. In reality, there is no force, because it's only the influence from the Sun. That means what we are calculating is that we have the inertial force and the gravitational force, and one is as the other, and then the Earth is following this curve around the Sun. But here we have a different aspect. There are some more aspects we have to consider, because if on daytime the field is more than on nighttime, the meter is smaller. That means my shoes are smaller on daytime than on nighttime. Mm-hmm. But no problem, because my
the food is shrinking as well.
That's it. And that means that if the Earth in this system is turning around itself from day to night, then we are always make this movement. And this movement means that the Earth is breathing between day and night. And it is interesting that the founder of the field physics, which is Rudolf Boskowitsch, has described this in his book from 1755. Already.
Fantastic.
This is his picture. I have it on my book. In English, Self-Consistent Electrodynamics. And this is Rudolf Boskowitsch from Croatia. He stems from Dubrovnik in Dalmatien. He had been a priest at his time and went to Rome as a professor, and but later on he got into a conflict with the church. It's clear because of his ideas, but he changed into politics. His town, Dubrovnik, at that time was called Ragusa, and Ragusa was a free town like Venice. And so they were in competition on the other side of the Adria. They were in Ragusa, and he was representing Ragusa in the rest of the world. And so he was traveling a lot, and he came into contact with Newton. And what we don't know is that it was Boskowitsch who made Newton famous.
Oh.
Yeah.
How?
Yeah, because he said this is a system in mathematics which is perfect, a perfect description, but he added, it is not everything, because the earth is breathing, and this is because the earth is turning in the field of the sun, but we are not able, so he is describing in his book from 1755, we are not able to detect this breathing because we are from the same matter as the earth. Perfect. Yeah, absolutely. And the book was his book was in Latin. It was called De Spatio et Tempore ad Nubis Cognis Cunctur. That yes, in English it is about space and time and how we are observing it. So this title shows it. This title could be from Einstein about space and time and how we are observing it. Perfect. So this guy, this physicist, was the first who has described in his book the basics of my theory of objectivity. But he has not been as successful as the one he was talking about.
Nobody has heard about him.
Well, Rudolf Boskowitsch is more important than Tesla in his country, because he was a scientist. He was a theoretical scientist, and long before Tesla was experimenter, famous experimenter.
Yeah, we don't have so much time left. What are the next plans?
Well, I still want to go further from these books to. I still have not described everything that has to do with this field effect to the meter, and the next book will have a title of what is Sündenfall of
sins. It's a biblical expression.
Yeah.
When they inflicted them with sins.
Yeah. It is the conflict of the physics with Big Bang, because how they explain the Big Bang today is in contradict to the equations of physics. Mm-hmm. And this I want to point out.
Could you perhaps explain what is the contents of your next book?
Yes, I want to talk about the Big Bang, especially the conflict the opinion of the Big Bang has with the rules of physics. I explained that these influence of the fields to the distance, to the meter, what 1 meter is, and what as well the speed is, that there is an influence. Well, we know this, we accepted this, that this is an important rule, because we know this from the rule of the square distance. And this rule, if you look from the other side, it means that the field is describing what 1 meter is, has an influence to how we observe the heavenly bodies and so on. So, if we look at our galaxy, we know that these galaxies are reducing slowly. So all these heavenly bodies, the stars and our sun as well, are moving on a
elliptic.
Yes, it is like a screw, like a screw. They're moving towards the center of the galaxy, which is a black hole.
Therefore, they call it black sun.
Yeah, I don't accept all these explanations, but we know that these black hole, that a black hole always is in the center of a galaxy. So, in my opinion, there is a movement that all the stars are moving. At the end, they are dropping into the black hole. Inside the Schwarzschild radius, they are captured. So they are accelerated, getting quicker and quicker, all the matter. So at a special point, they reach the speed of light. And if they are even more accelerated, they get speeds more than the speed of light, but which is impossible for matter. We know this. But if the matter is changing into the size of a neutrino, then it has the chance to get out of the black hole again. So these neutrino radiation is radiating from the black hole, which is the biggest neutrino source in our universe. We know this.
That must be because it's quicker than light, otherwise it wouldn't get out.
Yes, because light is captured, otherwise the black hole wouldn't be black. Yeah. Only particles which have the property of a neutrino have a chance to get out of the black hole. The property is that they are, well, they have a charge anyway. They are plus and minus, but in the average, the charge is zero. So this is only an oscillation all around this point, which is zero. And we can say that the average of the charge is zero, but the mean value is not zero. But if you want to measure it, you have to follow these oscillations, and our measurement devices don't do it. Okay, the same is with a mass, because if it is an electron, next time it is perhaps a positron, which is antimatter. So in the average, the mass is zero as well, and the average, not the effective value, which is different. So if the neutrino would be electron at one time, maybe it would capture it, but on the next time it is the antimatter, and then it is accelerated. So at the end, the neutrino is spreading out of the black hole, and this neutrino radiation is interacting with the stars. So the stars are using these radiation as a source of energy. And well, if the core of the sun, for instance, is interacting with these radiation, then something happens inside. I have a model about this, but
we take it in the next interview when we come to the practical consequences. This is only a sketch to show what is coming up in the next book.
Then the stars are using this radiation, and for shining, if they are changing the neutrino into a positron, we know that the effect is that we get light. If it is changed into electron, it is growing. We know that the sun is growing; it's getting a big ball somehow. And the third part, which is not used for shining, not used for growing, but is slowed down, but not yet to speed of light or less than speed of light, which is still a neutrino, but a weak neutrino we call it. This is called the solar neutrino radiation. And this solar...
It's coming, the sun winds.
Yes, this solar radiation is coming from the sun to the Earth and to the other planets here in the solar system. And the sun, by this not visible radiation, is supporting the planets with energy. And because the Earth is very small, and the strong radiation, which is much quicker than the speed of light, 1,000 or 1,000,000 times quicker, is too strong for the Earth, or the Earth is too small. So this is passing the Earth with no effect. But the weak radiation from the sun is influencing the Earth directly.
The weak neutrinos.
Yeah, the weak neutrinos. And the Earth is using them as well, is growing, is shining. Well, if you drill into the Earth, or if you have an earthquake on a volcano, then you see that there is light inside. Okay, but because of the crust it is not visible. Okay, and the third part is the radiation coming from the Earth at the end, which is the Earth radiation. And this especially is the neutrino radiation, very weak and usable for the plants and for the human beings as energy, as an energy source. So this is how I explain this movement of matter through the galaxy, which is a circle of eating and being eaten.
And how is this connected to the Big Bang?
Yeah. If we look at this point, we see that the whole galaxy is reducing in size. We know this from other galaxies which do the same. Mm-hmm. So if we are moving into one point, the other stars are moving to the same point. So we know that the distance from us, from the sun to the next, is getting smaller. We know this. And if we look at this situation by the Doppler effect, we know that if two bodies are coming nearer, we get a blue shift, and if the distance is getting bigger, we get a red shift. So we can observe from this color
change of the frequency
of light, we can say well, the distances get less or more. Mm-hmm. Well, we know that we the distance is getting less. So what we should observe is a blue shift.
But we see the opposite.
No, the stars, the other stars of our galaxy, we see nothing. We see no blue shift and no red shift. We say these are fixed stars. We observe them as fixed stars. But on the other side, we exactly know that the distance is getting less. So we should observe a blue shift. But we see no blue shift. What is the reason? And this is why I explained you that before. Because the field is getting more and more. The field from the center of the galaxy, which is supporting the whole galaxy with energy. That means all the stars are only shining if they are in the influence of this black hole. If I would switch off the black hole, they wouldn't shine and they wouldn't grow anymore at once. So that means if we are all in the influence of that black hole, then this black hole has the biggest fields and we are in this field. And that means, and the other stars of our system, of our galaxy, are in the same field. So if the field is getting more and more, the light is getting less and less. So the light needs more time to come to us. But the distance is getting less. So this one influence is compensated by the other. So at the end, we can't see it. We say these stars are fixed stars, but we know that a blue shift should be observed. That means if our situation, if the field in our environment is getting more and more, and if this is the reason why we don't see the blue shift, we, as a consequence, need to see a red shift to the others. If the distance is constant, even if the distance is constant, because our situation is changing, the field is getting more and more. That means the light from those stars from outside, from other galaxies, needs more and more time to reach us. But this has to do with the field of our detection system and of our observers. It has nothing to do with the distance to the stars that we have the redshift. The redshift, which is explained as the reason and the cause for the expansion and the Big Bang.
So I have learned.
Yes, as we have learned it, this is nonsense. Because if you have accepted that we don't see the blue shift, you have to accept the redshift. You understand? And you can't say today is Monday and we do not accept, or we accept the rule and the next day is Tuesday and we don't accept it. So this was what these physicists do is just the opposite what a scientist is able to do and is allowed to do.
Supposed to do, yeah.
Supposed to do. So this well, forget it.
And you have an idea what the Big Bang was, really?
Never exists.
There was no Big Bang.
No, there was not a Big Bang. You see, if all the stars show a redshift in average, I would say the cause is because we are changing. Our system is changing. This is why they call me the Copernicus from the Black Forest. Yes, Spiegel has done first. And this is my special title. Because what Copernicus did is that he said, we are not in the center of the universe. We are only part of it. And if the universe is changing, we are changing with the universe. We can't see this anyway. And so this is what Copernicus did, and I do the same. I say, if all the stars show a redshift, we first have to consider our situation, because it could be that our situation is changing.
All the stars out of our own galaxy. Yeah.
Yeah. So this, I think, needs to be considered. And to the students, I discussed the following. I say, have a look. There are some stars called pulsars, and they pulsing. Sometimes they are dark, and next time they give a flashlight, and then a dark again, because they have a movement. They are contracting, and if they are expanding, then you have a flashlight, and then they are contracting again. And if we, with our Earth, would be part of such a star, we would do the same movement. So that means the visible distance to the star would always be the same. Mm-hmm. Because if we are moving towards, because the star is reducing, everything is reducing, the field is getting more, and we can't see it. If we measure it, we measure all the same distance. We don't see that our center star is a pulsar. We can't see it. But what we are able to see is that all the stars in our environment, on the sky we see, are blinking in the same way. And what is a physicist of this Earth saying? He is saying, well, they are communicating with each other. They all have the same opinion that they have to blink. They are very intelligent. There is intelligence in our sky. He hasn't forgot that it is himself. So we have these physicists, middle-aged physicists, among our scientific stuff everywhere. I would say the majority of our physicists has remained staying in the Middle Ages. They have forgotten that Copernicus has told them that they have to change their view. And they are measuring only their measuring devices. They don't measure the reality because they are impossible to measure it. They have no chance, or they have no opinion what to do. There's a rule behind.
Do you have an idea how the universe was born?
Well, if everything is made by ball vortices, such a vortex is nothing else than an electromagnetic wave, which is by a disturbance rolled up to a ball. So we have two stable situations, two stable configurations. One is rolled up to a ball, and the other is the electromagnetic wave straight on, running straight on with the speed of light. These are the two situations, and everything in between has to decide whether to become the one or the other side. And if we think about a nearly empty space, the first which will happen is that electromagnetic wave, if there is something like an electromagnetic wave, an oscillation, this oscillation will suddenly form a ball, a vortex, which is as big as the whole universe. But the next which is produced will find this ball and will form itself to a ball, and then it happens that one is in the field of the other and vice versa, so they are reducing their size. And then the next ball is produced and it is reduced again. And so I think it still happens now at this time that from outside vortices are formed. If electromagnetic waves are radiated, they come to this inner part where we are, and there it is disturbed and is rolled up to a wall, And if this ball is coming to us, the nearer it comes, the higher the fields are, the smaller it is, and at the end it has the size of an electron or of a neutrino. So that means it's up to the energy the particle has. But these particles, if they're coming towards us, they have these very, very small size. And then they are interacting and so on, and with crash and so on. We know this, and matter is the result.
But concerning to your unified field theory, in the beginning there must have been the field.
Yeah, first the field, only the field.
And then the stupid question: where's the field coming from?
Okay. I say in my second book, I say that the field is only, an observant. What I observe, you see, it's nothing in really thing like matter or so. So it's only observed because I observe the electric field as a magnetic field and vice versa, if there is movement. So the main question is not what is electric or magnetic field. The main question is what is the movement. With no movement in this universe, there would be no star, nothing. The movement is the main factor. That there is a movement one against the other. I can't say an absolute movement. I can't say, because there's no center we are moving around. It's only a movement if I'm moving and what I observe is moving as well. And so if my movement would change, I would see something very different.
And where is the energy coming from for the movement?
If I get a vortex, that means if I roll up such an electromagnetic wave up to a vortex, then I have one part inside this ball vortex and the rest outside. And the energy outside the ball has the same value than the energy inside the ball. So if I would destroy the ball, the energy from inside with outside would give zero. In addition, because the energy, I derive the law of the balance of energy from my theory of objectivity. So this postulated law now becomes a physical background with my derivation, and this says that the energy of the whole universe is exactly zero. Exactly zero. But what we have is that we capture one half inside these ball vortices, which now is not able to touch, to observe. It is inside. We would have to destroy it. You see, and as long as we have a box with particles inside, which is a closed box, then, and if I don't destroy these particles, if that means if the number is constant, the energy is constant. But only as long as these particles are not destroyed. This is what was a fight between Tesla and Einstein. Einstein says E is mc square, no? As,
very well-known equation in the world.
And he says that mass can be changed into energy, or vice versa. Tesla said, that's nonsense. This is his original words. This is nonsense. Because, and he is explaining, I have destroyed millions of particles, of electrons, with my devices, and I have seen no energy. So when he was destroying the electrons, he he was destroying the vortex, and the result was 0. Well, this has been proved by the MIT, Massachusetts Institute of Technology. They have done an experiment with natrium atoms, the natrium cores of natrium. They were accelerating these atoms to a comb, double comb, and behind this they have seen only fields, only Fraunhofer lines and so on. So there was no particle at the end. There was mass before, and at the end there was nothing, only fields. That means they have destroyed huge amount of mass. If Einstein would have been right, there would be a big hole in the MIT would be been destroyed. You see, it still exists. They have seen no energy, no, and this proves that Tesla was right. That means if you these Einstein equation, as it's called, it's older. Well, Vogt has still tried to publish this equation, and his paper was denied. So the science in former times was as stupid as it is today. And this is why Einstein, he had been successful by the support of Max Planck, but the other one, who was much more famous at that time, Vogt, was ignored. Couldn't, yeah. But it was not from Vogt. The equation was older at all. So, but this equation, this Maxwell equation, this Einstein equation, says that mass may be changed into energy, and we use this for the atomic bomb and for the atomic energy plants, and this is why they needed this. They needed Einstein, and especially for the bomb, and this is why they needed this equation. But if you separate atoms in pieces, cut it in pieces, you don't change the number of elementary particles, of elementary vortices. So as long as you do this, if you only separate it in pieces, cut it in pieces, and if the number of particles is the same, then Einstein equation is correct. But if you destroy particles, then it's not correct.
And in an atomic explosion, the particles are not destroyed.
Not destroyed, no. It's only if you put into parts a big uranium or so atom. If you put it into parts, then these energy of mass defect, it is called, is used. In my book here, in my new book, Part 4, Potential Vortex, Part 4, I derive and I calculate this mass defect. Mm-hmm. Exactly, it's exactly what we measure. So you can look at the books. You see how to derive it.
Very interesting. Would you like to add something to the audience before we finish?
Well, I hope that my books will be translated soon, so that it will be available as well in English. But those who want to know everything the first have to read it in German, because I first write my books in German. And the translation is done by, well, I only control it. My English is not good enough. So I give it to some native speakers, and they do the job. But it always takes time.
Yeah, of course.
And I'm not sure whether this translation is really correct. I can't say that. I control it a bit, So
small risk.
it is better to read in German anyway, because this is the original text. And, well, book by book, slowly will be available. And I think that I will publish this theory in parts now in papers as well, because there are some colleagues who read only papers. No, they are reading no books. No. And I will bring these papers as well, peer-reviewed and open published, so that it will be available in internet. Well, in the past I didn't do that, because in that time when I collected only the material, it was not the time to write scientific papers. I had only very few peer-reviewed and published. But most of the papers were when I gave lessons or when I gave presentations on conferences, and they wanted to have this as a paper. Then some had been published at that time, but it was not my my focus. Now it changed, and now I have collected everything, and I think this will be very useful and helpful.
Yeah, thank you very much for this revolutionary and mind-boggling information.
Yeah.
It's really helping mankind forward.
Thank you for the interview.
Thanks, bye.